For decades, the Internet has relied on classical physics-electrical signals, fiber optics, and binary code. But as cybernetics grow more sophisticated and global data increases at an exponential rate, the limitations of our traditional digital networks are becoming impossible to ignore. In response, scientists are building something entirely new: the quantum internet. This is a communication system based not on electricity or radio waves, but on the strange and powerful behavior of subatomic particles. The concept of the quantum internet revolves around one extraordinary idea: transmitting information using quantum states, like the spin or polarization of a photon. Unlike classical bits, which can only be a 0 or a 1, quantum bits or qubit scan exist in multiple states at the same time. This is a phenomenon known as superposition, and it allows for far more complex and secure interactions. But the real magic comes from a property called entanglement. When two quantum particles become entangled, a change in one instantly affects the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. For the quantum internet, it is the foundation of something extraordinary: the ability to transmit information in a way that cannot be intercepted, copied, or read without being detected. In classical networks, a hacker can tap into a fiber optic cable, duplicate a signal, or steal encryption keys without anyone knowing. But quantum communication behaves differently. If an eavesdropper tries to intercept a quantum transmission, the very act of observing the particles changes their state. This disturbance is immediately noticeable to both parties. In other words, any attempt to spy on quantum information instantly exposes itself. This is why quantum networks are often described as unhackable. Scientists have already demonstrated secure quantum communication between cities. Some experiments have even transmitted entangled photons from satellites down to Earth, proving that quantum networks could one day span the entire globe. China has built the world's first major quantum communication line, connecting Beijing and Shanghai with a secure quantum encryption network. Europe and the United States are developing their own quantum infrastructures. It's becoming a technological race not for faster internet, but for unbreakable security. To understand how transformative this could be, imagine a future where bank transactions, government communications, medical records, and sensitive industrial data are absolutely secure. No supercomputer, no algorithm, and no hacker could break quantum encryption. Even the most advanced artificial intelligence would be powerless against the laws of physics. For countries, businesses, and individuals, this could redefine cybersecurity forever. The quantum internet also opens the door to technologies beyond secure messaging. It could enable distributed quantum computing, where quantum computers in different locations share entanglement to work together as one enormous machine. It could revolutionize sensing and imaging technologies, allowing us to detect gravitational waves, underground structures, or biological changes with unprecedented precision. The possibilities extend far beyond communication alone. But building a quantum internet isn't easy. Quantum states are delicate. They can collapse when disturbed by heat, vibration, or interference. Maintaining entanglement over long distances requires specialized equipment, like quantum repeaters, which are still under development. And unlike traditional networks, quantum communication can't simply amplify a signal when it weakens doing so would destroy the encoded quantum information. Instead, entirely new architectures are being designed using techniques like entanglement swapping and quantum teleportation to extend the network. Despite the challenges, progress is accelerating. Each year brings new breakthroughs in quantum memory, error correction, and long-distance entanglement. Major tech companies and research institutions are investing heavily. Governments are funding quantum infrastructure projects as part of their national security and scientific strategies. The quantum internet is no longer just theoretical lights emerging, system by system, experiment by experiment. There will come a time in the near future when your messages, your financial information, and your critical data may be transmitted over a network governed not by human-made encryption, but by the fundamental laws of physics, a network where privacy is guaranteed at the quantum level. A network that marks the end of an era of cyber vulnerability. The quantum internet represents a shift as significant as the invention of the classical internet itself. It will reshape cybersecurity, communication, computing, and even scientific discovery. The question is not whether this technology will arrive, but how quickly the world will adapt to it. Follow Tech Obsidian for more explorations into the science and innovations shaping the future of our connected world.